Today, we're going to pull back the curtain on this invisible force that basically runs our entire world. We're going to break down exactly what electrical engineering is, what it actually takes to become an engineer, and maybe most importantly, where this whole field is headed next. So let's just dive right in. But first, just think about it for a second. There is this invisible force that lights up our cities, that connects billions of us across the globe, and it's even powering the very device you're watching this on. The people who figured out how to harness that force? Yeah, those are electrical engineers. So here's what we're going to cover. First, we'll get a handle on what the field is. Then we'll simplify it way down into its two core ideas. After that, we'll look at the toolkit you'd need to build, where that can take you in a career, and finally, we'll peek into the future of this incredible field. So, let's start at the beginning. What is this discipline that has so profoundly shaped the world we live in? Okay, so the textbook definition is right there. But what does that really mean? At its heart, it's about using electricity and magnetism to build useful things. That's it. It's a field that really exploded back in the late 19th century, right when things like the telegraph, the telephone, and electric power started to completely change society. And when I say useful things, I mean pretty much everything. Seriously, the impact is just staggering. Electrical engineers are the ones designing the power grids that light our homes, the microchips inside our phones, the satellites that give us GPS, and even the medical scanners that save lives. They are literally the architects of our modern world. Now, a field this massive can seem, a little overwhelming. But here's the really cool part. You can simplify almost all of it down to just two fundamental ideas. Two pillars that support everything electrical engineers do. That's right. Almost every single application, whether it's a gigantic power plant or a microscopic chip, falls into one of two buckets. It's all about moving one of two things, energy or information. And here it is, the big split that really defines the whole field. On one side, you've got energy. This is the world of high power. Think huge voltages, massive currents moving through power lines to run a factory. It's all about raw, brute force. But on the other side, you've got information. This is the world of teeny tiny power, microscopic signals. We're talking about incredibly fast, precise signals inside a computer processor or beaming from a satellite. It's this amazing contrast between raw muscle and intelligent data. Okay, so how do you learn to control both massive power and microscopic data? Let's take a look at the core toolkit an electrical engineer has to build throughout their education. And look, there's just no way around it. This is a tough field. The ability to design the future is built on a really deep understanding of the fundamental laws of science. This isn't just about plugging things in. It's about understanding why they work right from the ground up. A typical university path follows this really clear progression. You got to start with the absolute basics, the language of science, calculus to understand how things change, physics for the laws of the universe. From there, you learn the rules of the game, like circuit theory. Then you get to the really advanced stuff, like electromagnetisms, which explains how things like radio waves actually travel. And it all leads up to your senior year, where you finally get to take everything you've learned and apply it to a real-world design project. But it's not just about the raw science. A great engineer's toolkit has a lot more in it. They have to be master problem solvers, using tools like CAD software to bring their ideas to life. They have to be able to work in teams, and maybe most importantly, they have to be lifelong learners, because the tech they work on is always changing. All right, so you've built this amazing toolkit. Where do you actually go? Let's talk about the real-world jobs and career paths. The opportunities are just incredibly vast, because the field itself is so broad. I mean, you could specialize in power systems, literally designing the grid that keeps all our lights on. Or you could jump into telecommunications, developing the next-gen 5G and 6G networks. Other people might focus on microelectronics, designing the chips that make our devices faster and more powerful. Or control systems, writing the code that guides self-driving cars and factory robots. Every single one of these paths changes the world in its own way. So where do these specialists actually end up working? Well, according to the data, a huge chunk, over a fifth, are in engineering services, basically working as expert consultants. The next biggest slice is exactly what you'd guess, electric power. But look at the rest. Engineers are all over the place, in R&D, building medical instruments, even in aerospace. It just goes to show you how flexible this skill set really is. And yeah, it's a profession that's valued very highly. According to the Bureau of Labor Statistics, the median salary is clearing over $100,000 a year, which really reflects just how critical these skills and responsibilities are. So what's next? I mean, the field has already given us so much, but its most exciting chapters, they're probably still being written. Let's look at the trends that are shaping our future right now. This is where it gets really mind-blowing. Electrical engineers are at the absolute center of solving our biggest future challenges. They're the ones designing the smart grids that we need to run the world on renewable energy. They're building the specialized AI chips that will power the next huge leap in artificial intelligence. They're creating the massive networks of sensors for the Internet of Things, and they're engineering the unbelievably complex hardware that might just make quantum computing a reality. I love this quote because it really gets to the heart of it. It's not just about maintaining the world we have today, it's about inventing the world of tomorrow and creating things we can't even conceive of yet. You know, from lighting up the entire planet to connecting it all together, this discipline has consistently delivered technologies that completely changed everything. So the real question isn't just what electrical engineering is, but what it's going to become. What's the next world-changing innovation? Thanks for watching.